Skyward.
Harness the power of the sun. SkywardSolarPower.com.
Okay, thanks, Ken. Hap, thank you very much, and I appreciate you giving Skyward the opportunity to come in here today and present to you and give you some information about solar. And today it's just going to be focused on solar electricity. So a little background on Skyward Solar Power Company. We are in Durham, downtown Durham, and we specialize in solar. That's all we do. So that's solar electric, photovoltaics, and solar hot water systems. And we're a full-service company, turnkey company, so all of our capabilities are inside, in-house. So we do all the design and installation from start to finish of solar systems. And today, I wanted to take this opportunity to go through the full stream of a solar electric system and go through the major components that a solar system is comprised of and take some of the mystery out of it for you. And then at the end, I'd like to touch base on the value of a solar system for a business, a company, and the various incentives that are so good today that can dramatically reduce the cost of a solar system by as much as 80%. So they're very, very strong. So we will move on to the nuts and bolts of the presentation. So what I wanted to do today is to take a solar system and break it down into manageable buckets. And these are the objectives that I want you to walk away from at the end of the presentation. If we think about solar historically, in the 70s, solar was ready to hit the big time in the U.S. But it didn't happen because the federal government didn't embrace it. So it died on the vine in the U.S., but it went overseas, and the Europeans embraced it in spades. And in fact, if you go to a country like Germany, 25% of southern Germany can be, and sometimes is, powered by solar electricity. It's huge there. Germany has more solar installed than any other country on Earth, and the growth there continues to be phenomenal. And that's interesting, because when you think about Germany, if any of you have visited Germany, or whatever you know about Germany, it's not exactly a sunny climate. In fact, it's pretty darn gloomy, but solar is very, very successful in Germany. And if you follow Germany around the globe latitudinally to where we are in the U.S., it aligns with Nova Scotia. So, point is, North Carolina, so much further south latitudinally, has a huge solar resource. Our solar potential is far greater than what we see in Germany. Other states have recognized this, like New Jersey, huge growth in solar. California, as you'd expect, huge in solar. Colorado, Arizona, New York, Massachusetts, Connecticut, all have very, very strong growth in solar. Well, solar is hitting North Carolina, it's here to stay. And we are also going to see strong growth in solar in this state. It is without doubt going to be a part of the energy generation pie. So if we take a look at a solar system, and we break it down into these four buckets, and go through each one of them, there are many, many different types of systems that are available for mounting, for the actual solar energy modules, the panels, the heart of the system, the inverters, and in fact for the monitoring systems. And let's start with the roof. And the reason we start with the roof is because that's where all of our customers immediately go to. Solar system goes on a roof. Not always the case. They can be pole mounted, they can be ground mounted. But a roof is a great place to put a solar system. It gets it elevated, out of the way, keeps it safe, keeps it away from vandalism or even theft, believe it or not. But it's a good place to put a solar system. Plus you can get it out of shading challenges. And there are lots of nice, unobstructed, shade-free square footage available for a solar system. So a roof is a good place to start. And that's where we'll go. But when we think of a roof as a solar installation company, there's a lot that goes into how we treat that roof, which is why we have this wheel of accountability up here. We need to make sure when we install a solar system on a roof that we truly, properly, professionally respect the roof. Because we could go in there and install a beautiful solar system and in the process wreck the roof. We don't want to do that. We want to make sure that we take care of that roof and leave it completely safe and warranties intact and no damage. So, if you were to call up Skyward Solar Power Company, we're going to want to do a thorough roof analysis of your building. And we're going to assess that roof for a number of different things. And if we go through this list, let's start with the condition of the roof. Of course, the condition of the roof, it's got to be good. There's no sense putting a solar system on a roof that is towards the end of its lifespan. If we do that, and 2 years from after the installation has been completed, there are problems with the roof, and the roof needs to be replaced, then of course, you're going to call us up, and we're going to have to unbolt the system, lower it down to the ground, new roof put in, and then rebolt the system. Headache, additional cost, you don't want to do that. So the condition of the roof is very, very important. It's not uncommon when I called to do a site analysis on the roof, and I get up on the roof, and in inspection around, say, conditioning units, that there is cooling and causing plumbing issues. When that kind of scenario presents itself, we put a stop to the project until that particular challenge has been properly addressed. The type of the roof. Well, the type of the roof, of course, is going to dictate what we do on that roof and how we mount the system on that roof. So if you are a big business, you may have a TPO, a thermal membrane, you may have an EPDM, you may have a bitumen, built-up roof, whatever that is, we've got to account for that particular roofing system, which will then in turn dictate what we do on that roof and how we apply the solar array to that roof. Dead load limits, of course, are going to be very, very important. They have to be properly understood. There's no point progressing along on a solar design only to find out that the dead load limits won't allow the way of a solar system on a roof. It is rare that we encounter a roof that will not hold a big solar system. Obviously, we're fine with a smaller solar system. But there are situations where we do encounter a roof that we will need to be shored up before the system can be put on it. That's not common. What are the obstructions that are on the roof? The roof is a great place to put stuff, various equipment, whether it's conditioning units, chillers, all kind of venting pipes, whatever. We're going to have to completely understand those obstructions because we're not only going to have to work around them, but we need to know what kind of shading challenges those obstructions are going to present to us. So we're going to do a shading analysis and take into account all of those obstructions that are on the roof. The roof warranty is very important. It could be a scenario where we will call up, say, Firestone or Carlisle or Sika, whoever has your roof, and tell them, listen, this is what we plan to do on this roof. We want you to sign off on this, and they may, in fact, send a representative from their company to do a spot check as we progress through the installation process. But the purpose of doing that is making sure that the roof warranty or the membrane warranty is fully intact and not voided in any way. The orientation of the roof. The orientation of the roof is which way is it facing? South, west, east. On a big roof, on a flat roof, it doesn't matter because we can orient the array, the solar panels, in the precise direction that we want to do it. If the roof has a pitch, then that pitch is going to dictate the orientation. Of course, we want, optimally, a south-facing orientation, because that will give us our greatest solar window, which will in turn result in our greatest energy production, our yield. The slope of the roof also will be taken into account as far as doing an energy calculation analysis. The roof to the control room, well, if you've got a big roof and you want to use the control room for placing some of your equipment, where is that control room in relation to the array? If we are going to use the control room to mount, say, inverters, what is the distance? Are we going to have to face challenges with voltage drop? Or can we get to that control room through the exterior wall going down into a control room? Are we going to do a roof penetration down into the control room? Wind loads. Our wind speeds here, anybody know what our wind speeds here are in the Piedmont area? Any guesses? We engineer all of our systems based on the base wind speeds here, where we are, central North Carolina, at about 95 miles per hour. As you go east, your wind speeds pick up. So if you get over to Wilmington, you're going to be at 130. If you go to the Outer Banks, you're going to be at 140. If you go down to Dade County, Florida, Miami, you're going to be engineering your systems at 150 miles per hour. So these are some of the characteristics that we're looking for and data that we are collecting on site analysis.